Before we go over another way or another theorem to show that two triangles are congruent, we need to review a couple of parts of right triangles. So you have a right triangle, which definitely has a right angle, in this case, angle C, and then the different parts of the right triangle. The two sides that make up the right angle are the legs. So BC is a leg, AC is a leg, and then the side opposite the right angle, or the side that doesn't make up the right angle, is the hypotenuse. So those are the different parts of the right triangle. And then we could use right triangles also to prove that two triangles are congruent. So another way that you could prove that two triangles are congruent would be specifically proving that two right triangles are congruent. So this theorem is pretty specific. You have to have right triangles, otherwise you would not be able to use it. The other two theorems, side, 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 and side angle, side, it didn't matter what kind of triangles that you had. But for the hypotenuse leg theorem, if you have a hypotenuse, so again, that's the side opposite the right angle, and a leg of a right triangle congruent to basically the same parts of a second right triangle, then the two triangles, or more specifically, the two right triangles would be congruent. Okay, so if I have a right triangle, again, it has to be a right triangle. And the hypotenuse of the right triangle and a leg, it actually doesn't matter which leg, it could be this leg or it could be this leg, but if the hypotenuse and that leg of the right triangle are congruent to the hypotenuse and the leg of a second right triangle, then those two triangles, more specifically the two right triangles, have to be congruent. If I made this triangle LMN, this triangle XYZ, then triangle LMN is congruent to triangle XYZ. Okay. That's the hypotenuse leg theorem.